In this video, we're going to look at the root test. The root test is very similar to the ratio test in that it has the three criteria. So the first one is if the limit of the nth root of the series is equal or is less than 1, then it is absolutely convergent. If the limit of the nth root of this sequence or series is greater than 1, then or goes to infinity, then the series is divergent. And the same restriction still is in place for this one. If it equals 1, the root test is inconclusive. And if the root test is inconclusive, don't try the ratio test, because the ratio test is going to give you the exact same thing and will fail as well. So you can't use the root test to test something that failed the ratio test and vice versa. So you do have to try something completely different. Let's look at an example of what the root test does. The root test actually is very simple in its calculations and a little bit easier to deal with than the ratio test. However, it will only work when you're doing something to the nth power, because the nth root cancels that out, which is what saves you the work. So there's a very limited use case for the root test. In this series, I have 2 to the n plus 3 over 3 to the n plus 2 raised to the nth power. So to do the root test, I take the nth root of that, which will leave me with just 2 to the n plus 3 over 3 to the n plus 2. I do the limit of that, goes to infinity, and I'm left with 2/3. Since the 2/3 is less than 1, therefore this series is absolutely convergent. And we're done with the root test.